Hello everyone, and welcome back to day 4 of iTalk series on Internet of Things by Mr. Saket Kumar. Thank you so much for joining, and without further ado, let's start the session. Now, I would like to request Sir to please take over.
Yeah, hi, good evening, everyone. Today the session is the controlling of Bluetooth module, servo motor, right? And also how to control robot, right? So robot means the controlling of servo motor or the different DC motor. So today we will see the connection of servo motor, and then we will control it through the joystick and then through the voice command, right? So first we will see, you can see the setup right now. This is the Bluetooth module which is already connected with the Arduino, and the Arduino Uno and the servo motor. You can see the servo motor, right? We can control the movement of the servo motor through uh, joystick, right? So we have the joystick right now. So these things we will perform today. Right now the Bluetooth module is connected with my uh, you can see that Bluetooth module is connected. Now it is connecting right now. So let's connect the Bluetooth module. First I am showing a demonstration, then I will go with the program and other things. Okay, you can see the connection has been successfully done, right? Now I will give a voice command, then you will see a value here. 1. 1. Okay, let's see, restart it. I will show you how to connect with this. Hello. Okay, I think I just reverse the connection of the Bluetooth because we need to take care about the transmitter and receiver pin. Now, hello. You can see uh, we have two question mark here. The reverse, that is the garbage value. So right now we are getting the garbage value from the Bluetooth module, right? It means we are getting something in the module. It means something is happening here, and we can see it. The value is coming, right? That is the garbage value. So don't worry about it. We are getting the garbage value here, but no problem. We will get the exact sentence also, right? With this app and the Bluetooth module. So we will discuss it later on. It's a simple code. Okay. So first, we perform the control of this servo motor. How to control this servo motor with Arduino. So you know that the servo motor can rotate at different angles, right? It can be rotated at different angles. Right now I have a servo motor which can be rotated in 360 degree, right? The servo motor which can be rotated at 360 degree. So I am connecting this servo motor with Arduino, and then I will connect this servo motor with joystick also, right? First I will directly connect the Arduino with servo motor. So I disconnected the Bluetooth module and I'm connecting the servo motor with Arduino. So first I will take a breadboard here, and in this breadboard I will try to connect the motor, and then I will connect the connecting wire in this breadboard so that it will be interface with the Arduino. Because whenever you will make a robot or a robo car, you need to interface the servo motor with the controller. Then only you can control the position of your servo motor, right? So I'm connecting here. Selected that one. Nature. So I'm taking a wire right now to connect with it, right? And then taking the connection like this so that it will fix the wire. Then we have another wire, and I'm connecting it here, right? Then we have another wire, and then we will connect it here. So we have three wires which is connected here, right, in the breadboard. And now we can connect these three wires with uh, the Arduino Uno, right? So the brown wire is the ground wire, so I am taking ground. Then the white wire is the 5 volt. Then I am connecting 5 volt, and this is the signal wire, the orange wire of this servo. I think it is visible to you. The orange wire of the servo is the digital wire, so I am connecting it on 11 number pin or 9 number pin. Why I connected this at 9 number pin? Because 9 number pin is the PWM pin of the Arduino, right? It's a PWM pin. It means we can change the duty cycle of this signal, right? And through which we can control the servo, right? Through which we can control the servo, right? Through which we can control the servo. So first let's write a small program for this. We have, I think we should have the program for servo. So we have this servo library. If you do not have the servo library, then you may install it through the manage library option, right? Or you can add this library. Well, when you will install Arduino, then you will get this library. And if you don't have this library, you can add with manage libraries, or you can add zip library, right? So this library will be added here. Now this is the servo variable which I am taking here, and the servo pin. So I connected the servo pin to 9 number, then I will write here 9. Okay, and then you can see in the setup the servo 1 dot attach servo pin. This is the syntax for the servo library, and then initially it is right at 0 position, right? Then it is moving in this direction, so I am just commenting it so that you will get first, you will get step by
Excuse
step
me, sir.
guide. Yes.
Sir, your screen is not visible.
Oh shit! I forgot to share the screen.
Yes, sir.
Now is it visible?
Yes, sir, it is.
Okay. So you can see the servo motor here. I need to repeat it again. Okay, no problem. We have Arduino. We connected this servo motor. We have three wires in the servo motor. The orange wire is the signal wire, red wire is the positive wire, and the brown wire is the negative wire of the servo, right? So we connected the signal wire to the 9 number pin of the Arduino, and then positive and ground, positive wire and the ground wire, right? Then we can see the program here. We have the program servo.h, and then we have servo pin connected at 9. Okay, so it's a very simple program. You can write it, okay, and you can rotate it. So first what I will do, I will just write the servo in a particular angle. So initially I am just writing here 90. So you can see the servo will rotate to 90-degree automatically on every reset. Okay. So it should rotate at 90-degree. So when you will see this is the servo. This is the servo. So when you will see this, then it will rotate 90-degree. So let's upload the value, and I hope it will upload, and it will rotate. So you see the servo. When I will reset the servo, I can rotate it, and it will come in the same direction, right? At this direction, it means this is the 90-degree for this servo. When I will write here 100, then you can see it will rotate. See, it rotate in a particular direction, right? And if I will write here 300, it will again rotate. See, it's rotated at this angle, right? So for this purpose, we can just rotate it at a particular motion, right? So I'm writing this. If I will take it as integer, for integer equals to I equals to 0, and I less than, if I will write here 300 and I plus plus, then it will rotate, and it is a delay. It means it will rotate at a particular angle with 0 to 300, right? And then after a delay of 200 milliseconds, it will again decreasing from 110 to 0. It means it will oscillate between a particular angle, right? So I am uploading this program so that you can see that servo will oscillate in a particular angle. So you can see the servo is rotating in a particular angle. You can see slowly it is oscillating at an angle. So you can assume the wiper of your car. The wiper of your car rotate at a particular angle, right? And it wipe the windscreen of the car. So this way the wiper will work. There is a servo motor which controls the motion and angle of the servo, and it wipes the windscreen of the car. So it's a very simple application. You can see the motor is rotating. Right now it's 300, so it is going to 300, but in the returning it is going to 110. So I am again writing here 300 so that the oscillation will be fixed. I think it is visible to you guys. See, after 200 milliseconds, it is coming back to the path. The complete path is going on. Even I need to see the delay also. We have not the delay. So this way you can control the servo motor, right? So whenever you will make a robo, then you can, like if you are making a crane system, then you can control the motion of the servo. Okay. So this way we can control the servo motor. Now I will tell you how to control the servo motor with the joystick. So in the yesterday, in the third day of the workshop, we see the interfacing of the joystick and it is moving in all the directions, right? So how we can control the motion, the forward and backward motion. So I will use only one servo and use this joystick, right, to move it forward and backward. Uh, okay. So we are just connecting this joystick with the Arduino so that we can see. I connected the wire, all the wires. Okay, I found the one more wire for this. So this is the joystick with all the wires. So I'm connecting it in the breadboard, or we can connect it directly to the Arduino. So I have only one power port in the Uno. This is the limitation of Uno. I have only one power port. So I need to use this power port in the breadboard, right? So what I will do, I will just take the power and I will make a parallel power line in the breadboard. You can see this make the parallel power line in the breadboard. This wire. Now I can use this line as a power line. Similarly, what I will do, I will just use the ground wire also because I don't want to use the ground wire of in the board again and again because I have only two ground wire. So I will use it in the breadboard. So you can see this is the power wire and the ground wire connected with the Arduino Uno. Still my servo is working. You can see my servo is working and it is rotating at the angles, same angle which we decide, right? Yeah. Now I will connect my joystick with this. So these two wires is the ground and VCC wire. So the ground wire will be connected here and VCC wire will be connected here, right? And then we have VRX and VR and Y. So we will connect these two wires to A0 and A1. So VY is connected to A1. Yesterday we discussed about the connection and then Vx will be connected to A0. Okay. Now we can write the program for joystick. So for the reference, I'm opening the yesterday program. Yeah, this one. So what I will do, I will just define these things, the same thing here, okay? And then I'm not using button right now. I'm just using these two things. So joy X and joy Y. So I'm just writing these two values. So you can see in this demonstration we already seen the value of this joystick. So I will use this. So I can first analyze the value of the joystick, right? First, let's analyze the value of the joystick in the serial monitor. So first, the value is X value. Okay, it means I'm using X because I don't want to use Y. So I'm using X because I have only one servo. I have only one servo, that's why I'm using only one direction of this servo, right? So I'm using X. Okay, in the X I will get the value. So I'm uploading this program again and I will use X value. So first I will analyze the X value in the serial monitor. That in which direction the X is going on and what is the value of X direction so that I can use and I can control the motion of the servo. You can see the ground value is okay. Right now the value of I and J is printing here. So I'm commenting these values because I don't need these values. I want my value X value, right? So you can see the X value is 516. In every loop it will print the X value. When one complete loop will finish. So the value is 500, right? When we will move this in the X direction, then I am getting 1016. So accordingly we can set it, right? So how we can set it? Now the X value is from 0 to, sorry, from 518. It means from 500 we can set a range of the value. First we will map the value of X, otherwise it will create some problem, right? So first we will map the value. It means integer y equals to map. The value is X value, comma. Then the initial value is 516. And from 516 to 1023, right? The value will be 0 to, or if you don't want to map this value, then okay, then there will be no any issue. If you cannot understand the concept, you can directly use this value 518, right? So what I will do, I will just write here if I equals to 518, right? It starts from here. I less than 1023, right? Then it will move in this direction. It will write the I, right? So it will go in this direction. But you can see we have only the value from 0 to 300 in the server. So we cannot use this directly, right? So if you don't want to use maps, then you need to use it, otherwise it will not work. And if you want this value, then okay, I will upload this value. You can see the 518 is the value, and then we have 1023. So first I will try to write this value in the servo and let's see it will work or not. Okay. So the initial value is 518 and I less than, it means then for I, we need to use the different logic here for I, because I have only I value. So we can write here, because it is a continuous loop, we can write a condition if I, a, sorry, or we can write here x value. We cannot write I, x value less than, um, or first I will write greater than equal, we can write here the condition greater than equal 300, sorry, greater than equal 518 is the initial value. So I will just increase the value from 518 to 1023. So I will write here the interval so that it will not give the error. So if the x value is greater than 550, then it will rotate in clockwise direction. I'm just setting here for the clockwise and anti-clockwise direction. So it will go from 0 to 300. Okay. If the x value will be greater than 550, then it will write, or we can just write here, the servo will write x value, or we can write here 300. First, let's see the joystick is working or not. So x value greater than 550, then the servo will write 300, right? And similarly we will write here else if x value uh, less than equal 500, then servo will write at 90 degree. Simple. The servo will go to the 90 degree. So this way we can see the uh, x value is working or not, right? So I'm writing here, uploading this program, and we can see the serial monitor also, and the servo also, and the joystick. Right now you can see the value is 516, right? Now I'm just moving this joystick in a particular direction, right? I just increase the value, then servo move, right? Okay. So whenever the value is changing from one place to another, then the servo is moving. Okay. You can see we can control the servo with the joystick. So this way you can control your robot. Now I have only one servo motor right now. That's why it is. I can show you only one demonstration right now for this joystick and servo. Let me search another motor so that you can see the controls of it. Okay. So you can see the motion through joystick. So this way you can control the servo motor with the joystick. So you can make the robot. Now the second really the second type of robot is robot with obstacle detection, right? To avoid obstacle. So whenever the robot will get the obstacle, then the servo should move, right, with the obstacle detection. If the obstacle will be near to the servo, then it should move so that or it should stop so that the servo then so that the robot will not collide with the obstacle, right? So how to make this such type of robot? So for that purpose you need this ultrasonic sensor, right? So I'm disconnecting this joystick. You can see the joystick is working right now. So through this, you can control the direction of the servo. I hope it will work for you. Now, I'm using this ultrasonic sensor to make it a obstacle avoiding robot, right? So I just connected it in the breadboard, and I will show you the obstacle. So I'm connecting this. This is VCC. Sorry, the red one is VCC, and the blue one is the ground. It is written in the ultrasonic sensor which is VCC and which is ground. So you need to connect this two wire with the VCC and ground. Okay, so this is connected, right? Now you will connect trigger and echo pin. So in the day 2 we discuss about the ultrasonic sensor. Now I'm going to show the application of this ultrasonic sensor with the robot. So I will connect this with the digital pin 1011. Okay, so you can see the trigger pin is connected on 10 and the echo pin is connected on 11. So for the reference, I will again open a program of ultrasonic. Right, and this is the code for this. First, you need to define again the pins. The trigger pin, which is connected on trigger pin is white wire and it is connected on 10 number pin. It will be written as 10. And then we have echo pin, which is connected on 11 number pin. Okay, now you can just take different variables and you can use it. So I will just declare the setup is, you can see the trigger pin is the output pin. So I will write here pin mode. Okay, and then the variable is trigger pin, and that will be output. Fine. Trigger pin is the output and the echo pin is the input pin. We will just pick this sensor and trigger pin and the next is echo pin. Echo pin is the input pin. Fine. Servo has been attached here. Now I just remove the joystick, so I will remove this. Also remove this. Okay. And here what I will do, I will just write these lines so that it will trigger the ultrasonic sensor to activate it. So yeah, the ultrasonic sensor will activate, and then we will write here float and distance equals to, or you can take it time. Time is the default variable, so we cannot take it. Duration. Duration is pulse in, and it will be echo pin. The same pin which is defined above, right? And it will work as high. Fine. Now you can see the algorithm. We have distance. So we can take the distance. So again I am taking float and just equals to duration upon time. Duration upon 2. So if you want the formula of this exact in centimeter, so you can just go to the Google and you can write here ultrasonic sensor, right? Formula for distance in Arduino. Then you will get help and it will show the exact distance of the formula. So you can see the speed of sound is 340 meter per second, right? And so speed is 0.034 centimeter per microsecond. So time is distance upon speed. So time equals to 10 divided by 0.034, right? It means 294 microseconds. Okay. So distance equals to speed into time. So now we have this time and we have this speed of sound and divide by 2, then it will give you the distance. So how to embed this formula to find the centimeter? So you have the speed. So speed into time upon 2. So we have the duration right now. You can see this is the duration, the total duration, and from one side the duration is this. So I can write here time, right? Time underscore sound. It means sound, but it means it will give you the time of sound, right? So duration by 2. Now you can find the distance in centimeter. How? You can just upload this formula, speed into time. And speed is, because this is in microseconds, it will give you the microseconds. You can see. So it will give you microseconds. So 0.034 centimeter. So you can write here float distance equals to 0. You can see 0.034, sorry, 0.034, right, multiply by what? Time underscore sound. It means this will be the time. Okay, divide by 2. You can see speed into time by 2. So you will get this formula, distance equals to 0.039 multiplied by 294 upon 2, right? So you will get this formula. So you have the time 0.034 into 2. So you will get the centimeter, the distance in centimeter. So I can just print here serial dot print. You can write distance equals to, and then here it will be serial dot print ln, it will be distance, right? So distance in centimeter you can write here. You can upload the program. So it will give you distance in centimeter. I will set the value later on. Eco pin was not declared in this scope. So I just did the mistake in the spelling, I think. Eco pin. Yes. Now it will upload. Again, one more error. The same error is there. Eco pin. It's a case sensitive, so please take care about it. Then we have x value was not declared in the scope. Okay, now I just remove the x value. So I'm also removing these if conditions right now, and then I will again write it. It will work. The servo definition is there. So you can see because I didn't use any delay, that's why it is showing like this. So if I will use delay, then it will show the exact value. You can see we have so I'm using here delay of 100 so that you can observe the value in centimeter. Now you can see right now the value is 40 centimeter something, right? Now how can I show you? I have the scale here. Hmm, Let me search the scale. Okay, leave it. So you can see the obstacle in front of this proximity sensor. Right now, you can see the 2 centimeter distance is there. So this is the approximately 2 centimeter distance, right? And then when I will increase this distance, then it will increase the value. When I will remove it, then you can see the surface should be reflective. Now you can see. Now we can set the program according to the obstacle. So how we can set the program? Just see the servo. We have this servo. Now I will write a program for this servo. If right, the servo is moving and using for loop for the servo. For integer I equals to 0, I less than equals to 360, I plus plus. Okay, so I am just writing the servo. I. Right. So right now, when I will pass this comment here, then it will show the complete loop, right? It will start rotating with this loop. So when it will start from I to 360, it will not stop. Okay. So it will not stop. So I will just use here the while command so that it will be the infinite loop. So I will use while I equals to 1 equals to 1. It makes infinite loop to the complete program, right? And now I will write here servo 1 dot write I. Okay, then I think it will work one angle or another. Let's see, servo will move or not. Integer type. Okay, I'm getting some error. Servo move at the particular angle, it is not moving, right? So if I'm using I plus plus here, okay. So we need to write here the loop so that it will continuously rotate in the particular direction so that we can stop it, right? So for that purpose, let's use another loop. Let's try another loop so that it will start rotating. Day less than equal to 360 plus plus. So here I'm using again the server one. It will check. Let's see it will rotate or not. Okay, we need to remove this while loop. It is creating problem. I'm just putting an obstacle here. Getting some error in the loop. Wait, let me see logic. First, it should show the distance and accurately. It is showing the garbage value right now. It should fix the value. Okay. Now I'm getting the fixed value, but with some garbage value also. Okay, let's use the another proximity. Might be possible that it is not working. Okay, so you can see a little bit noise between the values, right? Yeah, we have little bit noise. If I remove it, okay, then it will. So we have little bit noise. We will ignore this value. So now we can write the servo. According to the distance of the obstacle, the servo will work, right? So how? We can just move the servo in the for loop by less than equals to 300 and I plus plus. In between this, we can stop the servo, right? So how we can stop the servo? This loop will continue and it will execute all the commands of the proximity sensor, and then we doesn't need to use this delay here. We can just write here servo right, and we can move it in the angle of I, and we can write here if distance equal to equal to distance will be, or we can say the distance is less than equal to 3. It means right now I'm getting 3. If the distance is less than equals to 3, then then servo will write a particular angle and it will stop, right? It will stop here and it will write a particular angle I can define 90. It will stop at 90. Else, the servo will continue with the value of I. Okay, we can stop anywhere in the servo in the range of 0 to 360. So much noise is there. So you can see the servo is little bit to not moving. Okay, the wire has been connected here. It is not moving right now. Okay, let's use this eye, then see it is moving or not. Okay, so I think some problem is there. It is not moving. Let's use 200. Let's see the setup is working or not. These are the very delicate servo guys, so it's not reliable anymore. You can see it is not going to the setup. Okay, I think it's gone. No problem if we have launched this. So you can understand if you will set the logic, then it will show the distance and you can stop the servo motor at any point, right? Or if you are using DC motor, let me show you the DC motor. How can we control the DC motor with this servo? Let me show you the DC motor again so that you can control the wheels of the can control the wheels of the DC motor. So you can directly connect the DC motor with the board Where is my wire cutter? Okay, so I'm connecting the DC motor with the uh, Arduino, and you can see the ground pin is there. So I will connect the ground pin, and then I will connect the digital pin. And okay, you can see the servo is moving right now. I think some wire was loose, so you can see the servo is moving. Now I'm connecting this DC motor, and I will show you how to stop this DC motor through the proximity sensor. So I'm connecting this DC motor to 12 number pin, right? And I'm declaring the 12 number pin here, the DC motor. So this will define DC motor. DC at the pin is 12, right? And it's the output pin. And mode is output. So DC motor I connected, and that is the output pin. Okay, and here what I will write if I think the wire has been, now you can see the servo is rotating with again the wire. The problem is in wire, that's why it is showing the garbage value. Now you can see when we come near the 2, then it will stop. The servo motor has been stopped. And when we move beyond the 3, then it will start working. Right? But when we come near the, right? So the previous logic which we used, that is the for the proximity. Now I will stop DC motor with the same logic, right? So if the value which we are taking distance, it means the obstacle distance. Distance less than equals to 3. Again, right? Then what will happen? Pin mode, pin mode DC will be low. It means it will stop the motor, else pin mode I should write digital write, so that digital write will be high or low. So digital write, the DC should be high. Okay, so whenever we come with a distance less than 3, then the DC motor should be stopped. So let me show you the coupling of the DC so that you can easily visualize it. So let me connect the DC motor first, and then I will show you. I'm just screwing this coupler so that you can able to see the rotation of this DC motor. Now uploading the value. We see the program again. 12 number. So it is connected on 12 number. Fine. Then I'm using this out of this loop. I'm moving this loop because we are using the DC motor right now. Also this. Let me see that the DC motor will work because the size of the DC motor is a little bit larger than the Arduino which I am using. The proximity is working but DC motor is not working. So let me see that this DC motor will operate at this temperature or not. It is not taking the exact ampere, that's why it is not working. From the 12 on the pin. Separately, I try this. Just wait. Uh, as defined DC equals to 212 in mode, if DC equals to I, then digital write C. Let me try this. If it would be okay. So the Arduino is not giving the correct ampere. So let's try Mega for this. And let me try Mega. If Mega will give the exact ampere or not. So I'm trying Mega for this DC motor. I told you in the first lecture that sometime the Arduino Uno is not giving the ampere to the device. I am using a big DC motor, that's why it is not working. So now I will use 13 and 9, 10, 11. We'll just connect the connection in the same pin, ground, and this one will be in the ground. And this one will be in the ground. Okay. So I'm using Mega right now. So let's see. Mega will work for this DC motor or not. 13. If it will not work, then you can use adapter, power adapter to run this DC motor. Comp 14. Shifting the board again. When you will perform the practical on the hardware, then it will uh, chance to fail that hardware because sometime the wire has been damaged or something. You will get issues in the hardware, right? But once you will set up it, then it will not give you the issue. And if you are using the same hardware again and again, then definitely you will get issue. I'm using these hardwares from since long time. Done. Okay, I'm not getting the enough ampere from the digital pin. You can see the DC motor is not moving, but it should rotate in a particular direction. Okay, so for this purpose, we can use this relay circuit, right? If you are using power adapter, then you can rotate this motor with this relay circuit, right? If your motor is little bit bigger than the limit of this Arduino board, then you can use the power adapter to run this motor. Yes. So I have another small motor. Let me try this. Concept of today's class is clear that you need to control the motor from the Bluetooth device, from the proximity sensor, so that you can make your own robot, right? But it's unfortunate that my hardware is not working right now. But in the same manner, you can control your robot. The same program will work for your hardware if you have a proper hardware. Yeah. So I'm using this motor. This motor is working. So but it's a very small robotic motor, and I don't think that it will work here. And you can visualize this motor. But if I use a page in front of this, then you can use this motor. You can see the vibration of this motor. It's a small DC motor, you can see, and if we use this, then this motor is working. Now you can see the vibration. So this motor is working in this condition. Yeah. So you can control the motor with this proximity sensor. Okay. Unfortunately, my motor is not working, but in the same manner, in the same algorithm, you can control the motor. Fine. So now I am showing you the program of Bluetooth module which we were discussing in the starting of this tutorial. So how to connect Bluetooth module with the Arduino so that we can get the exact value and we can connect it through the mobile phone, right? So for that purpose you will get different tutorials here. You can see we have so many tutorials for this to control the Bluetooth device for the light, right? So you need an Android app. So few developers we have who are giving the free Android app like this, AMR Voice. This is giving the free voice recognition demo, right? So which we can see the example and we can connect it with the uh, Bluetooth module, and you can connect the robot with your Bluetooth module, right? So if you will see this, then let's do this particular experiment, and you will see the connection between the Bluetooth module and the mobile phone, so that you can control your robot through Bluetooth. Mm, we need few wires for this, few female wires. Okay. So in this Bluetooth module, we have 5 pins. You can see state, RX, TX, ground, VCC, and enable. So we need to connect VCC, ground, RX, and TX pins only. We will leave enable pin and state pin, right? So it's a Bluetooth pairing. So you will connect only 4 wires with this Bluetooth module. So VCC, then ground, then TX, and then RX. Okay. So you will connect these 4 wires with the Bluetooth module, right? And simply you need to connect this with the Arduino, and you will get power in the LEDs. So I'm connecting VCC and ground. You will get the blink light here, right? The light is blinking right now. So you need to install this application. It is available on the internet. AMR voice, BT voice control for Arduino, right? And you will get this voice, and it will translate the value. It will value of your voice to the Arduino software serial monitor, right? And you will get the signal. You will get the message, right? So you can search if you are not getting this particular project or this tutorial. You can search here simply voice control voice uh, text and Bluetooth to Bluetooth Arduino. Then you will get this tutorial. So many tutorials you will get like this, in which you can transmit the Arduino Bluetooth speech in the see OK Google we have. When you will say OK Google, then it will give the command. Then we have another voice control app. So you can see the simple connection. All the tutorials are there. You can see the connection. You can use software serial to connect this. Okay, so you will get this in the serial monitor. Simple. Okay, similarly you have same tutorial here. The code is same for all the tutorial. You can see the program is same. It is just checking the availability of the serial monitor, and it is reading the value of the serial monitor. Right? If voice length is bigger, then it will use and it will turn the voice into the sentence. So I am showing you an interrupt to the Bluetooth. So first you can see the mobile phone. When I am opening the app, first I paired the Bluetooth device with my mobile phone. If you can see, HC05 is the device. I think it is not visible to you. Let me reduce the brightness. You can see HC05, right? Is the HC05 is the device, Bluetooth name. I connected it, I paired it, and then this is the application where I'm opening this Bluetooth module. Just click and connect robot. So you will get the list of your Bluetooth devices here. So here you need to select HC05 and you can see the message. It is connecting. So if the connection will be successful, then again I will go to the Bluetooth device and try to connect this app with the Bluetooth device. It is showing unable to connect. So go to the Bluetooth setting and forget this device again and then unpair it, and then you will get here the next device. Just click on it and you can enter the pairing password. Normally the pairing password is 1234. Right now I have the pair device, so I will go again with the connect bot and I will connect HC06 with the. Now you can see it stops blinking. Right, Bluetooth device has stops blinking. Now what I will do, I will just connect this RX-TX with 0 and 1 number pin. So connect TX with RX and RX with TX. So it will connect TX and the RX will connect to TX. Now the connection has been successful. So I uploaded a small program here, right? It will show the impulse. If serial will be available, then it will read the value. Now I will just click on it and I will open the, you can see the baud rate is 9600, I think. Yes. So I'm just tapping on the voice and I will tell something. Hello. Hmm, okay, let's remove the wire again. Let's see. Hello. See, I'm getting hello here, right? I'm getting hello here. So it means this is the keyword which I am getting here, right? Now, whatever I will tell, it will transmit through the Bluetooth to the system. So this is the Bluetooth device, this is the application. So I will Arduino programming. So you can see now green. You can see the next character is green. And star and hash is the breaking character for the particular line. Okay. So you can see the program. Now you can uh, apply the condition here, multiple conditions, if you are getting the voice message from the Bluetooth device. Okay. So first what I will do, I will connect the LEDs, and I can blink the LED through this voice command. Um, okay. So we have the LED right now. I'm connecting this LED to the 13 number pin. And this way you can control your robot also, right? So I'm writing here, my Bluetooth device has been connected, and let's check again that it is connected or not. Green. It is passing the value right now in the serial monitor. Now I can use, I just connected the 13 number pin with the LED, so I'm writing here LED at 30 number, right? You can connect the motor also. Let's define the pin mode, LED output. Okay. Now I'm writing a condition here. If uh, I'm getting the voice message, right? Hello, green, etc. So I'm just writing here the text if voice equals to if voice will be equals to star green hash. Okay, then my LED will turn on. I will just write here digital write LED high. Okay, so it will hide the LED if I will say green. Now else if I am telling red, then what will happen? Will turn off the LED. So we can control the LED through voice. Now I am giving else, it will blink. Or we can keep it low so that there will be no any confusion. Let's try this program, it is working or not. We are getting the commands here, we are getting the voice here. Now let's see. So we need to remove the RxTX pin. We already discussed it before. Otherwise, it will not upload the program. Pin connected. Let's see it will work or not. Green. Clearing the output. Again, I am seeing it. Green. Nothing happened. Let's check the connection of Bluetooth. It is connected or not. You can see the Bluetooth device connecting. It's connected. Green. Okay. Let's reverse the wire. I think green. Now I get green here. Green. Okay. So I'm getting this. So just change this light to this message to this and uploading the program again. The same problem is there. You need to disconnect the wire first. It's uploading right. Okay. Again, I am connecting. Fine. So I am getting which type of message I am getting? Red. The star one. Okay. So I'm again using here without star. I think it's delimiter. Let's see it will work or not. The message is transmitting from the Bluetooth device, but you need to set the correct command in the program, otherwise it will not work. Red. So get this. Green. Getting the correct command, but it's not working. green. The onboard light is glowing right now. You can see the onboard light is glowing, but the LED is not glowing. Red, red. Okay, green. Okay, now you can see the LED is glowing. Okay, now red, red, red. It's not transmitting the correct value. You can see it's transmitting red when the LED is not glowing, and then green. The LED is glowing. So this way you can control the motor also. If you will see, if you will say clockwise, then the motor will rotate clockwise. If you want to control different LEDs light or the bulb or your motor with the voice command in your boat with the voice command through Bluetooth, then you can use this app and you can control your Bluetooth device with the mobile app, right? You can control the servo motor in a particular direction. So for that, let's see how to control the servo with this command, right? If I'm telling you the servo can be controlled with this command, then how it can possible? So you can try at your home. We have the servo motor right now. You can see. So we can control this servo motor through the voice command, and you can use the Bluetooth module for this, right? So I am using this wire. Okay. Let me connect it again so that you will get the demonstration of the servo motor with two different commands. Fine. So we have the servo motor right now. We need to connect this servo motor with PWM pin, that is 5. Then we have these wires, ground and power. Okay. Now HC05 has been disconnected, so I need to connect it again. So let's connect. It's connected with HC05, right? Now I'm showing you how to control this servo motor with the voice command which I will give here, right? So I will just write here for the servo. So we have the servo program right now. We need to find these three lines and just declare here my servo is connected at 5 number pin. Okay, and then it will be servo. In the setup I'm giving servo and here I'm giving 0. It means initially the servo will write to 0 degree angle. Okay, this is the final one, guys. How to control servo motor with the voice command. Okay, So we connected the servo with file number pin and the servo write to 0. Now what I will do here, I will just write the servo in the for loop. So I am removing this LED, or you can keep this LED. If voice equals to green, then LED will be glow and it will rotate the servo motor from I equals to 0 to I less than 300, less than equal 300 value, and then I plus plus. Okay, I'm using for loop inside the if condition, and then I'm writing here servo 1 dot write, and here I'm just writing I. Okay, so what it means, whenever I will tell green, then it will rotate to 0 to 300. And similarly, in the reverse logic, when I will tell red, then it will rotate from 300 to 0. I minus minus. Okay, so I'm uploading this program. Let's see it will work or not. Whatever I get. Integer, okay. Integer I. I. It should be greater than, sorry, greater than equal 0. So you can see the motor has been rotated to 0 degree angle right now. Now I am using this voice command green. So you can see the rotation of the motor, right? It's rotate from 0 to 300. Okay. If I will give delay here, then it will rotate slowly. And see, red. Again it move in the 0 angle, right? Green. Different command will begin. Green. Now you can see on the voice command, the servo motor is rotating. So if you are using 4 DC motor or servo motor, then you can control it with your voice, right? Voice command. And this is the main basic function of how to control Bluetooth robot, right? Basic function. So in the small duration of time, we cannot construct the complete robot here with all the parts, but you can try it at your home with the same application, and you will get the servo motor, and you can easily control this servo motor with the Bluetooth device. And the connection is very simple and it is already available. So whenever I will tap here, red, red, red. So you can see again it rotate, right? Green. See. So this is called as Bluetooth communication with the electronics app. See, I'm not using any Node MCU, I'm not using Raspberry Pi, I'm using simple Arduino. You can also connect Arduino Nano or Arduino Mega or Arduino Uno. Right? You can see on the green we have this LED which is glowing, and on the red it is not glowing. So I think that's it for the today's session. Uh, Anmol, are you there? Am I audible?
Yes, sir.
Uh, yeah. So, Anmol, I think I covered the today's session Bluetooth device and the controlling of Bluetooth device.
Yes,
So,
sir.
tomorrow we will discuss the Raspberry Pi setup.
Okay,
Okay.
sir. Yes, sir.
And
Sure, sir.
yeah, tomorrow we will discuss the Raspberry Pi setup. How to set up the Raspberry Pi with the system so that they can use or they can uh, get the idea about the basics of the Raspberry OS and Raspberry Pi.
Yes, sir.
Okay.
Sure, sir.
So I'm finishing the today's session here.
Yes, sir.
Thank you
Thank you
guys.
so much,
Thank
sir.
you so much. Can you stop the live broadcast?
Yes, sir. Shubham.